All right. Now, since we've dropped the ball, which had potential energy, what we want to do is find out how much potential energy it had. So you can see here, we found out in yesterday's video, that potential energy is mass times gravity times height. That actually comes from the work equation because gravity is applying a force to the ball, which is mass times gravity, and the distance through which the ball falls is h. So, in order to calculate the potential energy, I'm going to need to know a couple of things. I need to know the mass of the ball, I need to know gravity, which is 9.8 meters per second squared, and we need to know height in a metric unit. So first, let's find mass. I didn't know the mass of the ball, but I found an easy way to get that. I balanced it using a ruler and using some stuff I found in the kitchen. When I add up the total mass over here, the mass of the ball is roughly equal to 103 grams, which is the mass of my bars over here. That is 0.0103 kilograms. Now, to get the height, I didn't have a metric measuring tape, so I measured 7 feet up the wall. So I need to do some unit conversion. 7 feet is the same as 2.1 meters. Hopefully you can do the same thing. Now, how do we calculate the gravitational potential energy? Well, as you know, potential energy is mgh, and potential energy is then the mass times gravity times the height, and when you put that in a calculator, we end up with 2.1 joules.